All right. Welcome to the wonderful world of IPv6. Yes, IPv6 is a part of this new CCNA as well. You're never going to get rid of IPv6 unless we go to IPv7, which I don't see it happening in our lifetime. All right. So let's go over the basics, right? Things you probably already should know or you're about to know. IPv6 is a 128-bit address. We know this. All right. It's in hexadecimal format. You have 240 undecillion addresses. We cannot fathom that. I can't fathom that. The only analogy that I have for you is just, I don't know where I read that, where it says that if you take a grain of sand and you fill up a truck, a dump truck, that will be IP version 4. If you take a grain of sand and fill up the sun, that would be IPv6. So think about that. All right. So you have more than enough addresses, and within that's the complete total of addresses. What you have per subnet is 15 quintillion addresses. For you math geniuses out there, you can go ahead and look it up. It's there. All right. But that's you don't have to worry about that site anymore. All right. Good things is if we have no broadcast. There is no broadcast. There is no ARP anymore. All right, it's been replaced. So we have no more ARP. Cool. All right, no broadcast at all. All right, so and of course it brings new features. So what are those new features? Well, we got a new type of addresses. Yeah, we got Anycast address, the 1 to nearest. Okay, meaning this address, which comes from the range of linked local addresses or unique linked local addresses, it comes from there. And what happens is that address can be in multiple places. Let's say you have servers and you have multiple servers with the same address. You're looking for a particular service. Okay. So you look for that address, right? Your routers, obviously, because it's always based on the metrics of your routing protocol, what it's going to configure. Okay, who's nearest to me that holds this particular service and is going to go there first. Okay, so you can have, let's say looking for a service in a particular router. Since we're talking about routing. All right, you have 8 routers that have the same address, but you're looking for the nearest router to you. But that's all based on your routing protocol, right? That's why they say is 1 to nearest address. Okay, so we have the Anycast, the linked local address. That's new. That's the FE80. All right, that exists on every interface. Okay, it exists on every interface automatically. It's like the replacement of a PIPA. All right, that's always going to be there. It's always going to be there, and it does a lot more things than what the PIPA used to do. Okay, global unicast address. Those are our public addresses. All right, we have transition mechanisms such as dual stack, 64 tunneling, and NAT64. We'll be seeing a dual stack lab in here as well. We have the EUI64 auto configuration. What is that? Well, instead of putting an IP address, we just put the network prefix of the address with the prefix length, which is that slash whatever, but there's no slash anymore. Okay, the prefix length, and then you go EUI64. And what it does, it takes that 48-bit address or MAC address of that interface and pads it, like it says right there, pads it with a triple FE smack in the middle of the MAC address to turn it into a 64-bit address, giving you the interface ID portion of the address, meaning the host portion, if you want to call it that, of the address. So brand new stuff, EUI64, very nice, very nice. All right, smaller header is a 64-bit, 120-bit address actually. All right, but the header is twice as small as the IPv4 because they got rid of that. Well, you can always put it back in if you want to, but by default, it's a very small header, okay, which makes it more streamlined. ICMP version 6, boy, this guy's got a job and a half. Why? Because it looks for router solicitations, router advertisements, neighbor solicitations, neighbor advertising, dad. Who's dad? Duplicate address detection. ICMP version 6 is responsible for all that stuff. He's make sure that, hey, is there, when you ping somebody, dad goes out there with you and finds out, hey, is there an IP address out there the same? Is everybody unique? Yeah, we're all unique, dad. So dad comes back and says, okay, everything's good to go. All right. So duplicate address detection. If you have 15 quintillion addresses, I don't think you should have an issue. But regardless. But this also, just to give you a heads up, not in the exam, but because of router solicitations and router advertisements and all that, very difficult to work with IPv6 in the network and creating access lists and working with certain third-party applications because they still don't have support, meaning it's wide open. Now with this BYOD, bring your own device, okay, it's wide open. You can't block ICMPv6. If you block ICMPv6, you literally just bring down your network. So you need to find a way around that, okay? Not in the class, not in the course, but just to give you a heads up for out there in the real world, okay? So think about what you're going to do, because I know there's a third-party application out there that, it maintains and monitors and assigns and does everything for you, but with IPv6, yeah, not yet, okay? Not yet. But anyway, just know that this is what it does, and do not do it in a practice lab first before you put it in production. What is it you're going to do to secure your IPv6 network? All right, here's a breakdown of the IPv6. The first number here, starting from left to right, this is your registry, right? 2001, the registrar, Aaron, whoever, all right? They're the ones that give you this, all right? 2001. Then your ISP gives you this particular number, 3200. And hey, well, the company, guess who this is, right? Facebook, or if you want to, whatever you want to call your company, there's a company address, all right? So we're under this ISP, and the registrar is giving us this public address. So we're going to be using all that. This portion of it is where you're going to subnet. This entire thing is your network prefix. And each one of these sections or fields, whatever you want to call it, is 16 bits long, which gives us our 64-bit portion of the network prefix. Now on this side, we have our host ID or your interface ID. All right. This is where, you can make whatever combination of numbers you want, really, if you wanted to, or we can use that EUI64, whatever what you want to do. Each one is also 16 bits long, okay, making it a 64-bit interface ID, giving us that 128-bit address. And this is no longer called a CIDR or a subnet mask or a slash anything. This is your prefix length. All right, same thing. If you were to turn all this into binary, that means 64 bits out of the 128 bits are on. All right, so that is the default line that you see here. That's where the break is right here between the network prefix and the interface ID or host ID. Okay, that normally people use because they're not that familiar with IPv6. They're not comfortable subnetting in IPv6. So you can always say, if you don't know what the heck you're doing, just put a 64, you're good to go. All right. All right, so that's how this is broken down. And this is an example. Now, this is for short expression, but this is how you see it. See, 2001, 3200, bad. 2000, and then 0015. Then you got the 0ABC, 000, 001, and then 64, right? Well, there's a way, because writing all this, and, Notepad is your friend for this because you're going to be copying and pasting left and right. All right. But there's a way where you can get rid of, it's called the rules of leading zeros. The rule of leading zeros. Any zeros in front of a number, you can omit. Any zeros in front of the numbers, you can omit. So as you see the numbers that have turned into red, this address will look like this. You take out the zeros from the 15, take out the 0 from the ABC, and you take out all the zeros, consecutive zeros over here, and you'll truncate it to one double colon. And there's another rule that's called you can only have one double colon in the entire address. You cannot have two double colons. You cannot have two double colons. You can't do that. Because if you would have had, say, consecutive zeros over here, you would have to then put a 0 here and then have that double colon, or vice versa, have the 0 here and the double colon over here. But you cannot have two double colons. That will be an invalid and illegal IPv6 address. You're not going to jail or nothing, but you can do it. All right. And here's another example of the same thing, but look at that. All these zeros and 12. You can go ahead. I put in 0 so you can see that I just put 10, 10, 10. Okay, and I took out the zeros from the 12, but I could have easily just put one double colon right there because they're consecutive zeros. All right, and I could have put a double colon and then the 12, it would have been even shorter. So this is the rule. So this is a very legitimate question that I myself used to put on test. Okay, that just, hey, identify a valid IPv6 address. Something simple. All you gotta know is one double colon, and you can take out the leading zeros, the zeros in front of the number. Like, see, can't take out those zeros here, can't take out those zeros, but I can take out the zeros in front. Okay. All right, that's what they consider short expressions. Now, the types of addresses are linked local. The NeoPIPA, it exists on all interfaces. Now, zone IDs, what does it mean by zone IDs? If you have a multi-home computer, let's say, and using IPv6 on your PCs, your servers, what have you, it'll use at the end of the address an actual number, a percent and a number. That's called zone ID. So when you're pinging, it'll know which way it needs to go, which NIC card it needs to travel through. It'll use that zone ID as an identifier to go where it needs to go. All right. And here are your unique local addresses. All right. They're the same thing as private IP addresses. And this is where they acquire the anycast addresses as well. All right. And you see here, 1 to near is used the range of unique local right here. And this will be an example. IPv6 address, 2002, Saturday 128, anycast. By putting anycast, you're saying, oh, this is an anycast address. Okay. Then you have the double colon. That's the same thing as using all zeros for IPv4. Here's your loopback address that exists on every single interface. It still does the same thing, but that's just the IP version 6 of it. Here's using a mixture of IPv6, right, 2 double colons, and an IPv4 address. So IPv6 with IPv4. This is the range for global unicast addresses. So that's why you see that normally I use 2001 or you can use 2002. All right, so whatever that is, you can go ahead and put. You can always figure it out if you put it in binary. And then this one here is used for transition mechanism 64 tunneling. All right, if you're going across on the internet, going from router to router to router, and you want to go, 64, you can do it with these type of addresses. All right. So these are the new addresses. Again, you can memorize. These are the main ones they ask you about normally. Oh, and I skipped over the multicast. Multicast addresses you need to know, especially this right here, where I have, again, this will be available to you, where I have the FF029, that's for RIP, that's the multicast address for RIP. FF0210, that's incorrect, it should be A. That 10 should be A, because in hex, 10 is A. All right, and then FF02, 5, and 6 for OSPF. Those are the kind of questionings I think they're more geared to that you would see. All right, like the link local and mixed environment and anycast. But anything you see with FF, that's a multicast address. FF. If it starts with FF, it's a multicast address. Period. All right. Now, when we start routing with IPv6, before we get into this, when you start routing with IPv6, number one, even assigning an IP address to an interface. If you know you're going to start doing IPv6, the first thing you want to type when you get to global configuration is IPv6 unicast routing. IPv6 unicast routing. All right, you need to put that in there. You need to put it in there. Is there a hyphen between unicast routing? Yes. Okay. IPv6 unicast hyphen routing. You can tab it. You can question mark it. Look at it. The command is there. IPv6 question mark. And then you'll see what it says, okay? But you need to turn that on in order for you to do, especially routing in IPv6, plus other features for your protocols and even in the interface, okay? But now they really have made it easier for us to go ahead and route in IPv6. Now, this is deadly, right? Static routing, it was bad enough in IPv4, but now we go IPv6 route, the destination and network, actually that will be the network that you would put here with the prefix, the network with the prefix, and then the interface you want to go out by, all right? So you put IPv6 route, the network prefix with the prefix length and the interface that you want to go out by, Okay, that's how you would do it. But we're going to be doing a lab on all this, so there's no big deal. RIPng, all you got to do is go into each interface of the router that you want to participate in the RIP routing process and just IPv6 RIP. Now, this number is a process ID number, all right, to keep track of a local database. All right, so you go IPv6 RIP1, enable, done. You're done. You don't have to worry about advertising networks, no auto summary, class full, class less. None of that stuff exists anymore, okay? So all you gotta do is just enable the routing protocol in the interface. For EIGRP, it's a little bit different. You do go to global configuration. You put in IPv6 router EIGRP 100, okay? You gotta turn the protocol on. And then within router configuration mode, there's another EIGRP command which you need to put in a router ID in the IPv4 format. You have to do that. And then you go to the interface and you go IPv6 EIGRP 100. That's it. This protocol is a little bit whatever, but it's not bad. Or you're still doing the same thing you would always do. IPv6 router EIGRP and the autonomous system. Turn on the protocol by saying no shut, and then within there you do EIGRP router ID and just give it like you would a loopback address 1.1.1.1 2.2.2.2 whatever it is, and then go into each interface that you want EIGRP enabled and do IPv6 EIGRP and the autonomous system. Done deal. Again, there's a lab for this, so it'll be okay. All right, now OSPF, pretty much same thing. IPv6 router OSPF1. You got to put in a router ID, because once you put in the 1, it's going to give you a little message. Hey, you can start the process without giving it a router ID. So you go ahead and give it a router ID. You're good to go. Then you go into the interface, and this is where you go IPv6 OSPF1 area, and whatever area, I put area 51 here just to be funny. But obviously, you know that in the real world, what you want to do is area 0 for the very first time. Area 0. Okay, area 0. That's your backbone area. Now, remember, you must type this first when routing in IPv6. Like I said, IPv6 unicast -routing. All right. And the above will allow routing in IPv6. Right. This command will allow you to route in IPv6. And finally here, we're going to round off the chapter with subnetting in IPv6. Okay. You're going to learn how to subnet. You know, this is the fourth section. I told you already. This is how we're going to subnet in the fourth section. And then we will break it down in binary. I use positions. This is my little method, okay, of using positions. And again, there's a lab that we're going to go over there. And then remember, these numbers are in hex. That's one of the hardest things for us to remember, that these are hex numbers. Because we see this, we think it's 1,000. No, it's not. It's 1000. Each one of these values is 4 bits long. 4 times 4, that's 16 bits. That's what makes this section 16 bits. Okay, remember, you're still working in hex. And what I mean by positions is right here. So you got that 1000. There it is right there. You see I broke it down into binary. Position 1, position 2, position 3, position 4. Why is that so important? Because once you draw your line, like we normally have been doing, the bit value to the left, that's how you increment. All right, that's increment. So we got a lot of things that we're going to do, all right, in IPv6. Not only in this particular section that deals strictly with IPv6, but later on in the course when we do other protocols or other types of labs that deal with IPv6, so you can see what happens. Okay? I'll see you in the next. All right, now it comes time to start assigning IPv6 addresses to our router's interface. And that's exactly what we're going to do inside this particular lab. You see the IPv6 networks that are there. So we're going to go ahead now. No more talking. We're going to go inside and get this done. I'll see you there. All right. Welcome, everyone, to assigning IPv6 addresses to an interface. Now, obviously, you've seen already what an IPv6 address looks like. Here they are. And yes, they have been subnetted. So this is what we'll talk about subnetting towards the end of this section. But the PCs already have their addresses, their IPv6 address. So you have one here. We're using the 56 prefix length. And F is going to be the one for the gateway. All right. Now, even though we know we have quintillion addresses and all that good stuff, so don't worry about it. Okay, we have enough addresses to go around. So let's make sure that it's there. 14.1, 14F. That's good to go. All right, so let's go into router 0. And let's go ahead and configure IPv6, right? Or let's put IPv6 addresses on our interfaces. Now, one of the things that I said already, all right, let's give this a host name. Let's call it router 1. R1, okay? Is one of the first things you do when you're configuring IPv6 is eventually you will have to do the routing portion of it. All right, you want to enable, you want to do, yes, IPv6 unicast routing. Had a little brain mishap there. My synapses were not kicking. All right, but you need to turn on IPv6 unicast routing, because if you don't, you will not be able to route in IPv6, and certain protocols and things that you want to configure in IPv6, you won't be allowed to unless this is turned on. So regardless of what I'm doing, if I'm doing IPv6, I'm going to turn this on. All right, now we're going to go into the interface. And let's see what interfaces we're dealing with here. And let's bring it over here, because this is IPv6, and as I said previously, Notepad's going to be your friend, because this is a huge address, correct? So we're going to interface F0/0, enter, and anything you do with IPv6, you have to start off, obviously, with IPv6. Just like that before you did IP address, well, here you do IPv6 address. And then we do 2001 colon 3200 colon BADD colon 1000 colon 1. And the cool thing is we can do a prefix length right here, 56, and you hit enter. How cool is that, right? No more typing out 255, right? No, none of that. All right, so we just assigned to the F00 that address. Now we're going to go to the F01 interface F0/1, and that one is 1200. Okay, so we're actually going to cheat here. I'm going to copy this so I don't have to type it. Yes, and I'm going to paste it right here. But I will make a change because we said it was 1200. And before I hit enter, I'm going to verify again because, you know, the memory, the synapses is not going on today. Hit enter and then do a no shut. And that's it. That's all there is, as long as you got, you know, the correct prefix length, right? You don't have the IPv6 addresses overlapping each other. You should have no issues. Now, if you want to look at it, you cannot do show IP in brief. Because it'll be like, yeah, we have no IP addresses, because you're looking for the IPv4, right? You said show IP in brief. Now you got to say show IPv6 in brief. And there we are. Here is our fast Ethernet address right here. And here is the one between the two routers. Now, what do you see here? FE80 sounds familiar, right? We went over this. This is your link local address, your link local that will exist on every interface. Okay, it will exist on every interface in your router. All right, and if you do a show IPv6 route, not IPv4, right? An IP route, show IPv6 route, you see that you are connected, all right, to the 2001 3200 bad 1000. All right, you are connected to that. And here's giving you the exact address that you're connected to. All right, and here's the multicast address that will always be there as well. Okay, all right, so we got that router done. Let's go ahead and minimize that. Obviously, this is still showing that it's down because we haven't turned it on yet. All right, so let's go ahead and open this up here. All right, so we'll enable config T, host name R2, hit enter. Let's see which interface we're going to do first. Let's do the F00. Okay, well, let's just put it right there. Okay, so I can see it. Interface F0/1. Ha ha ha. All right, and then we're going to do IPv6 address. And we'll do 2001:BADD:1200:2 with a prefix length of 56. And we do a no shut. And now it should turn on. Now we're going to go into the int F00, I'm pretty sure. So it didn't give me an error, so that must be true. And yeah, F00. And what network is that? That is the 14 network. Okay, 14 network. So again, I'm going to cheat. Oh, I think I did something incorrect. Also, let me see. Paste. 1400 we said, right? Yes, we did. And this is going to be F right here, which is, I believe, we didn't do in the one over there. No shot. WR. Let's take a look. Show IP and oh, I was going to do that. What wasn't I? Show IPv6. Not 5. That was previous. Show IPv6 int brief. And there are our IP addresses. Let's take a look at this router again. So I want to make sure that I have the correct gateway for my LAN. Show IPv6 int brief. See, this is what happens when you get for copy pasting. Okay, you don't want to do that. All right, you don't want to do that because that's the actual IP address of the computer. So we go back in there, no biggie. Now, the only thing when if you make a mistake like this and you have to go back and fix it, you just can't put in a different address that it will override. No, because in an IPv6 world, you can have multiple IP addresses or IPv6 addresses within that interface. So you need to do a no IPv6 address and take this out. Okay, hit enter. Oh, it would be nice if I'm in the interface. Interface F0/0. And then I'm just going to go ahead and copy paste this. Okay, incomplete command. Oh, I forgot the prefix length, 56. All right, so that's gone now. But now I'm going to up arrow. I'm going to change this to an F. And then I'm going to do a Control A. Look at that. It takes me all the way over there. All right, I'm going to hit enter. Then I'm going to do WR, copy that information, Control Z, show IPv6 int brief. And now we have the correct default gateway on the F00. All right, so we're going to copy this particular address right here. Copy. All right, let's minimize that. And let's go to our PC, go to our command prompt, and see if indeed we can ping that address. And we sure can. No ARP, so it goes straight to it. So we have connectivity with our gateway. Now we can't route, obviously. We haven't done any type of routing. There's just assigning an IP address, or an IPv6 address to the interface. But let's check from between router to router. All right. So we're going to go ahead and copy this. And we're going to ping. Now I'm going to paste. And that should be 2, not 1. And I get a reply. So what we did was correct. So I'm just going to save that. All right. Not very difficult. Not very difficult at all. It's just cumbersome because there's a huge address to type out. So we copy paste a lot. Be careful. We don't make the same mistake I just did there. But if you know how to fix it like we did, we took out what was there and put in a new one. All right. And then we verified. We verified that we had connectivity. And we do. All right.
I'll see everybody outside the lab.
All right. No big deal, right? Copy paste. Copy paste. All right. That's what you can do it. Unless you already know the number, you can go ahead and type it in. But again, all you gotta do, remember IPv6 unicast routing, then go inside the interface and just assign the address. And the cool thing is that since there's no more subnet mask, there's a prefix length, we can just go CIDR whatever. Now you can see that I put F for the FAT00, I put 1 over here. Okay. Well, the computers already have theirs. I use the number 1 for the computers, but the default gateway is always F. But you can make it whatever you want. All right, but that's it. That's all there's to it, to assigning an IPv6 address to an interface on a router. Also, just want to add, be careful, because in IPv6, to take out the address, if you say you made a mistake, you need to say no, take out the IP address that's there, and then put in the new one, because you could put multiple IP addresses in an interface in IPv6. I'll leave you with that. See you in the next one. All right, now it comes time to route. First type of routing, though, static. All right, so we're going to do static routing with IPv6 for each one of these routers. We already have their IP addresses put in there. Now it comes time to start telling it, hey, these networks exist, go get them. All right, so let's go inside the lab and get it done.
All right, so here you are inside the static routing lab for IPv6. Now, obviously, you can see you have green lights all over the place because the IPv6 addresses, since you already know how to do it, they're already in their interfaces and everything's being turned on. The PCs have their IPs and their prefix length and their default gateways assigned. So all we need to do is route. We need to tell router 0, hey, you have a network that's beyond that serial 001 interface, which is right here. All right, that's these 3. So we need to tell them that those destination networks exist, because he only knows about directly connected neighbors. And we're not doing dynamic yet, we're doing static. So we're gonna go ahead and open up this router. We'll bring it over here. That's good right there. And then let's begin. Now I already have typed IPv6 unicast routing, so it's not a big deal. All right, so all we need to do is do IPv6 route the 2001 colon 3200 colon BADD colon 1100. We're starting with the LAN first, just because, and a prefix length of 56 out my S0/0/0 interface, and hit enter. Now I'm not going to type all that again, so I'm just going to up arrow. It's going to come out the same interface. The only thing that changes is the network that I want to go to. Now I want to go to the 1400. That's between the 2 routers on top. And then for the last LAN is going to be 1200. So let's go in there and change it that way. I wasn't about to type all that all over again. So let's do a DWR. Let's do a Control Z. Let's do a show IPv6 route. Take a look at our routing table. So you can see that we do have static routes. And let's open this up a little bit more so we can see more information. All right, so we got connected routes. All right, and we have static routes. Static routes, you see them right here. Okay, so let's see if we can ping. Well, we're not going to be able to ping yet because they are all of these static routes. So let's continue forward before we start pinging. I got ahead of myself. Now this middle router knows about these 3 networks. But you need to tell them about this network right here, and you need to tell them about this network right here. All right, so let's go ahead and do so. Let's open up router 2. We'll do a config T, and let's extend this a little bit more here because an IPv6 address is not small. IPv6 route. I want to go to the 2001 colon 3200 colon BADD colon 1200 colon 56 out which interface. Now, since this is the router in the middle, make sure you put the correct interface. In order to get to here, you got to go out this particular interface. That's the one thing with static routes, whether it's IPv6 or IPv4, you got to make sure you tell the correct interface. In this case, it will be S000, S/0/0, and enter. Oh, I forgot a 0. There we go, and enter. Now we'll do the other one, which is obviously going to be S001. Okay, oh, what did I do here? I got rid of the, there we go, S001. And we're going to get rid of that 1200 to, I believe, is 1000. And let's verify. Let's move this out of here. It is 1000. Very good. So we got the 1200 going out the serial 000, and we got the 1000 going out the serial 001. So we got that done. Do WR. Do show IP, just to verify, IPv6 route. Okay, and the static route entries are there. As you can see, there's the 1200 right there. And where's the static route? Right here. Here's the 1000 right there. Perfect. All right, let's go ahead and do the last router. Now, the last router, I'm going to bring these guys all the way over here. This router knows about these two networks. Now you got to tell them about these three networks. Just like the other router, the very first router, we had to do that as well. So he knows about these two. He just doesn't know about those three. All right, so config T. And then IPv6 route. I want to go to the 2001 colon 3200 colon BADD colon 1100 colon 56. Out what interface? Well, I already know that's going to be the S0/0/1 because I know I see the 000 there. So I'm going to hit enter there. So I'm just going to up arrow for the next one. And now 1100 is going to be 13. Hit enter. And then the next one is going to be 1000. They're all going out the same interface. Very simple. This is how you will create routes. So it's essentially the same thing. You're telling it the destination network, okay? And you're giving it the prefix length with an IPv4 will be the subnet mask. And then what interface you want to go out by. That's all. It's the same thing, but now it's just in hex numbers and a longer address. All right, let's verify that indeed they're there. Do show IPv6 route. Okay, and we see the static routes are there. So let's, from right here, let's go ahead and go privilege mode, and let's try to ping 2001 colon 3200 colon BADD colon 1000 colon F. That will be the actual interface of that router. And we can get to it. So we are routing. Let's go do an up arrow and let's go ahead and put the 1100. So we are routing an IPv6 using static routes. Again, just, since it's so long address, it's very easy to get a typo, put in the wrong IPv6 address, then we put the wrong prefix length. Make sure, again, like any static routes, you're telling it the correct interface that is going out by. And do not forget to enable IPv6 unicast routing. I'll see you outside the lab.
All right, that wasn't so bad. You gotta be careful. Gotta be careful. You saw how that up arrow works pretty good. And or copy paste, whatever it is. But you gotta be very careful when you're putting it because you need to make sure you put the correct exit interface. All right, you gotta know the actual, well, in this case for router 0, you gotta know, hey, I don't know these networks, and then you gotta go ahead and put them in there. All right, you can't make a mistake, especially in the middle router when you gotta go to this network, it's the S001, and when you gotta go to this network, it's the S000. Just like IPv4. The only thing is now we're using IPv6 addresses. And it's kind of different because it's the network. You actually write IPv6, this network, and that's the prefix length altogether, and then the exit interface. That's it. That's all there's to that. All right, pretty simple. And you saw how we got connectivity going across. All right, that's static routing and IPv6. See you in the next. All right. Now we go into dynamic routing. Yes, but I took out the static routes. So we got a clean slate. So we're going to do RIPng. All right, RIPng is pretty simple, as you're going to see. All right, pretty much all you got to do is just enable it on the interface. But I'm going to show you what it does also. We'll look at we'll do a show start. We'll take a look at, see how it's on the interface, and then how you see it later on down there. So you really don't have to go into global. You could, but you don't have to. Okay, but you definitely need to go inside the interface and enable that protocol there with its particular process number. I'll see you there.
All right, so that was static routes that we did in this particular lab, but the static routes have been removed. Yes, because now we're going to go ahead and do dynamic routing. And we're going to start with our favorite protocol, routing protocol of all, which is RIPng. Now, they've made it easier, to be honest with you, while in IPv6 to do a routing, because all you really need to do, especially for RIP, is just go in the interfaces. I mean, you need to go in the interfaces in all the routing protocols. But in this one, all you really need to do is go in the interface and enable it with RIP with a process ID number that will identify that particular instance. Let me explain. Very simple. It doesn't want networks to advertise, nothing. Just enable RIP on that interface. So here we have two interfaces, as you can see. So we're going to go into config T. We're going to go to interface F0/0, and we're going to do IPv6. I'm going to question mark it, okay, so you can see it. And these are all things you can do. What we want to do is RIP. Okay, we're going to do RIP IPv6. RIP what? There's that word. Okay, RIP 1. And then what do we want to do? We want to enable it. We're not doing default information because, as we know, that's to get out to advertise to the other routers. Hey, this is the way out to the internet. All right, and we're just going to enable it right there. And that's it. That's all there is. So I'm going to copy this. Copy. And I'm going to go to the other interface, which is int s0/0/0. I'm going to hit enter. And I'm just going to paste it. Boom. And I'm done. But look how cool. I didn't have to go into global configuration. I'm going to do a show start. All right. There's a IPv6 unicast routing that must be on, obviously. And you can see where I did right here. There's the IPv6 RIP1 enable, right, under F00. And there's the IPv6 RIP1 enable under the serial. But you saw that. But what I want you to see is this right here. Where did this come from? This you could do it in global configuration and then hit enter and then go into the interface and do this. But if you do this anyway in the interface, it's going to show up here, as you can see. So why even bother? So let's go there. Let's go to this one, which has 3 interfaces. So let's move this way, because we really don't care what the networks are. We just need to say, okay, which interfaces I want to use, participate in the RIP process. So config T, interface S0/0/1, and I'm just going to paste because I have it in memory. That's it, right? And then I'm going to do the S00, and I'm going to paste. And I'm going to do the int F00, and I'm going to paste. I mean, it doesn't get any easier than that, does it? Do WR. And then I'm going to go to the last router. And again, we got 2 interfaces there. We're going to go int S0/0/1. And I'm going to paste. And then the fast Ethernet, int F0/0, enter. And I'm going to paste. Done deal. Okay, Control Z, WR. You guys got to do copy run start. It's just me that I'm used to doing WR. All right, so now let's take a look at the routing table. So show IPv6 route. Now you see we're getting updates from the 1000. We're getting updates from the 1100. And we're getting updates from the 1300. So let's see who indeed we can ping all the way over there. So we'll ping 2001, 3200, BADD, 1000, ::F, right? That's the fast Ethernet interface. And we can. Let's go up. Let's change it to 1100. And we can. And now we also have the 1300. And I believe that's going to be in between. Yeah, that's in between the routers. Yeah, that's in between the routers. So 1300, let's just put 1. And that should be the IP address. And we have connectivity. But now we have connectivity using the RIP show IPv6. I wonder if we will do that. Incomplete command. Oh, group 1, probably. Nope. Okay, let's see. Oh, database. Okay. Is there anything else? Okay. There we go. And now it's showing us that, hey, this is what's on the routing information base, right? Show IPv6 RIP database. That's why we chose a number. As you see, the process number is 1. And then you can see the metrics that it took, all right? Timer, when it expires. So you know that we're running the IPv6 version protocol and we're getting updates from all the networks that we need to, right? You can just do the show IPv6 route to look at that, but here, so you can see that that number that I chose, that 1, is actually the process number for that particular local database. That's why I can copy paste over across, because that database is local. All right, I'll see you guys outside the lab.
That was easy. That was simple. I mean, come on. You don't have to worry about networks or any exit anything. You just got to enable the protocol on the interface. IPv6 RIP 1 enable. Done. All right? You just go to each interface and type that. All right? Can't get any simpler than that. And we verified that we had connectivity across. We looked at the routing table. Can't do show IP route, show IPv6 route. Right? And it was working. Pretty easy, right? Nice, straightforward. So far, so good. That was routing with RIPng. All right? Pretty easy. See you in the next one. All righty. EIGRP version 6. But we're not going to remove RIPng. Why is that? Because of the administrative distance. Just because it's IPv6, it's still RIP. So that's an administrative distance of 120. And EIGRP version 6 has an administrative distance of 90. So who's going to take over? EIGRP. All right, so you'll see how that happens. You see how that works. Let's get inside and let's get this done.
All right, here we are in our next routing protocol lab, which is EIGRP, as you already know. All right, I did not take out the RIP routing protocol, and why is that? Because the administrative distance is still 120 of RIP, and the administrative distance of EIGRP is 90. So it will override whatever RIP has, okay, and EIGRP will be placed into a routing table. Now the difference is just it's an IPv6. So slightly different, not that much harder. You still need to enable it on the interface, but we got to do some things in global configuration. So let's go to the first router, router 0. Okay. So we're going to go config T. We're going to do IPv6 router EIGRP, and obviously we need an autonomous system, so we'll use 100. All right, but question mark here. There's a couple of things that you need to do while you're here. One, never before heard, we have to turn on this particular protocol. So we need to do a no shut. Okay, and as well, you can see there's an EIGRP specific command. It's on like in the EIGRP address family, you want to call it, or the EIGRP family. So we do EIGRP, and what is it looking for? It's looking for a router ID. And the router ID, and let's type in R, that's the only thing that starts with R, is in a IPv4 version format. So we're just going to use, this is the very first router, so we're going to do that. Okay, so we got that done. Okay, we got that done. You went ahead and you actually did what you normally would do, but this time IPv6 router, EIGRP, and the autonomous system, which is 100. Then you turned on the protocol, and then you went into EIGRP family, let's call it that. All right, or subcategory, and we put in the router ID in IPv4 format. Now we do the same thing we did for RIP. We got to go to the interface F0/0, and we're going to go IPv6, and let's question mark it. What do I want to do? EIGRP. EIGRP. What does it want now? Oh, it wants the autonomous system. 100. What else does it want? It doesn't want nothing else. Oh, so that's it. IPv6 EIGRP 100. Okay, I can deal with that. Let's hit enter. Do WR. Let's go down. Oh, let's minimize this, I should say. Let's go to the middle router. Let's maximize it because we don't care about the networks anymore. Not that we don't care, is that we don't need to put them in. So IPv6 router EIGRP, same autonomous system, right? We need to turn it on. We need to do EIGRP router ID, and this is the second router, so 2.2.2.2. Okay, oops, and hit enter. Go into the interfaces. So we got all three interfaces in here. We got the int S00/1 0/0/1, and then we do IPv6. Okay, now IPv6 EIGRP, and then the autonomous system, which is 100. All right, and then we also have, that's the S001. We need the S00, and then the fast Ethernet F0/0. Okay, and then IPv6 EIGRP 100. Do WR. Okay, just WR. Okay, there you go. My typing fingers are not typing. And let's just, because I'm not seeing any adjacencies or neighborship relationships being made, so this is concerning me. So let's do a do. No need for that. Show IPv6 route, and we're still having RIP run on there, which we should not. Okay, it's not build any adjacencies, so that is an issue. So before we go any further, let's see what we did over here. Okay, let's look at the show start. Okay, unicast routing's on. It's always been on. F00 IPv6 EIGRP 100. That's the autonomous system. We did it. Oh, look what we didn't do. I didn't go to the S000 interface. I didn't do that. You see how quickly we can find out what the problem is? All right, so let's go to int S0/0/0 IPv6 EIGRP 100. Hit enter. Boom. There we go. That's what we want to see. Okay, we're going to start doing this again. Okay. Control Z. Let's do a show IPv6 route. And now we have these. Awesome. With a mix of R's because we haven't configured the last router yet. All right. So we got these on there. And now we'll do EIGRP on this last router. Enable config T. IPv6 router EIGRP 100. We're going to no shut to turn it on. EIGRP router ID, and there's the third router, so 3.3.3.3. Okay, remember, router ID is just the name of the router. Just to, hey, this is who I am. That's what it's doing. Okay, so now we go to the interfaces. Interface S0/0/1 and IPv6 EIGRP 100. Boom. There's your adjacency. And we'll go to the int F0/0 IPv6 EIGRP 100. Do WR. And from right here, let's go ahead and take a look at what we have. Show IPv6 route. So now there is no R's. We're learning about the 1300, we're learning about the 1100, and we're learning about the 1000. So let's ping. And you see how I overwrote for RIP. So RIP got out of the way. So ping 2001, 3200, BADD 1000, ::F. And we're pinging. Let's up arrow. Let's change that to 1100. All right, so we have, and that's still on 1300, and we'll ping with the 1. We have full connectivity across our network, but this time we're using the EIGRP protocol. I'll see you outside the lab.
EIGRP was pretty simple, wasn't it? Now, you know that we have to go to global configuration, IPv6, router, EIGRP, the autonomous system. Turn on the protocol, no shot. In there's a subcategory for EIGRP to put in a router ID. Then we go into the interface and we go ahead and enable it. Okay, that's it. But see how easy it is to make a mistake? I had to go back over here, didn't I? I forgot to put it there. But you know, this is real troubleshooting. If everything's perfect, how are you going to learn? You got to make mistakes so you know how to fix them, right? So when I saw that I wasn't getting any adjacencies, I'm like, something's going on here. So that's why we had to go back. And yep, sure, did it sure start? Sure as heck. I didn't go ahead and put, I didn't enable IPv6 on that particular interface. When we did, wham, the adjacency came right up, right? So IPv6 is pretty simple, and you saw that it overrides RIP. It took over the routing table because of its administrative distance. Simple, simple, simple. I'll see everyone in the next one. It comes time now for OSPF, right? Now we have an issue here because EIGRP has the lowest administrative distance out of the 3 routing protocols, right? That's 90. RIP has 120. OSPF has 110. But I don't want to get rid of EIGRP. I don't feel like doing it. Okay? So what we're going to do is we're going to lower the administrative distance of OSPF. Okay? So no more said. When we get inside the lab, you'll see how it's done. So you don't have to hear my voice anymore. Well, you'll hear it anyway, but you don't have to see my face anymore. Let's go inside. All right, here we are inside the lab. Now we're going to do OSPF. But I didn't take out EIGRP. And EIGRP is the lowest, right, between RIP, EIGRP, and OSPF. EIGRP has 90 as the administrative distance. So one of the things that we're going to do here, all right, is actually not take out EIGRP, but change, I should say, change the administrative distance in OSPF to just a little bit lower than EIGRP. We'll probably put it to 80. So it'll look at that. We'll be lower than RIP, and then we'll be lower than EIGRP. So let's go ahead and give this a try, shall we? Let's go. All right, we're going to do config T. All right, and then we're going to do IPv6 router OSPF 1. Look what happens. Well, I should have given you a message that says, hey, can create the process once you give you a router ID. So we're going to go ahead and put it in the router ID, all right? And it's going to be in, again, an IP version 4 format. So we're just going to use 4.4.4.4. All right, and we're also going to give it a distance of 80, okay? So EIGRP is 90, so now we're telling it that OSPF is 80. So that can make it to the routing table, all right? Then we go inside the interfaces, interface F0/0, and then we're going to do IPv6, OSPF, the process ID number, right? Yes, the process ID number, and then the area, which is going to be 0 because it's our backbone area, and in reality, that's what you would do for your first OSPF configuration. Your first routers will be your backbone area. So that'll be that. Do WR.
Let's go to the next one. All right, let's maximize this, guys. All right, so we're gonna do config T, IPv6 OSPF, or router OSPF, I should say. Router OSPF 1. There's the message. All right, so now we put in the router ID. We use 4, let's use 5. And then let's change the distance to 80. All right, so let's go into all the interfaces. S0/0/1, IPv6, OSPF 1, area 0. All right, so then we go into the other interface, which is 0. Okay, and then we do IPv6, OSPF 1, area 0, and then the fast Ethernet interface F0/0, IPv6, OSPF 1, area 0. Now, regardless, I should have gotten a full loading done that created a neighbor relationship. I have a sneaking suspicion that I did the same thing. I forgot to put it on this interface right here. So, pretty sure that's what I did. Let's go ahead and go to that interface. And this, okay, we got RIP, we got EIGRP. So now we're going to do config T. And then we're going to go interface S0/0/0, IPv6, OSPF 1, area 0, DWR. That should be working. Now you see the adjacencies getting done. So that means it did overwrite. Well, hopefully it'll overwrite. We'll look at it when we do the last router. Because we already did this particular router, correct? Yes, we did. Just to make sure. Yeah, we did. All right. And then let's go to this router now. All right, and we'll do the same exact thing. Config T, IPv6, router OSPF 1, get that nice pretty message. Router ID 6.6.6.6. And then distance, change the distance to 80. Then we go into interface S0/0/1, IPv6, OSPF, process ID, and the area is 0. Boom, full loading done. All right, interface F0/0, and then we got IPv6, OSPF 1, area 0. There we are. Let's take a look at our routing table now. Just clear all this gibberish. Show IPv6 route. And now you see that by changing the administrative distance, now the EIGRP disappeared. And you can see that we have the 80 that we put in as the actual administrative distance of OSPF, which is really 110. So, but we want it, because we're lazy, we just wanted to keep EIGRP there. We didn't want to take it out. So now we just ping, like we've done before. So let's ping, but this time, you know what? Yeah, I'm copying this. Copy, paste, and then it's F. Connectivity, up arrow, what is it, 1100? Connectivity, and then always verifying. Remember, I was always telling you that. Always verify. You never, and especially if that's what they're telling you in the test, make sure that you accomplish, that you verify that everything is done that you're supposed to do. So now we have, and it is funny if you look at it, because you're going to see all 3 routing protocols in there. Okay, but remember, what did we do? RIP by default, or not, RIP by default is 120. All right, that's his administrative distance. EIGRP is 90. It's lower than RIP, so that took over. And then we deliberately changed the distance for OSPF to 80, so you see all 3 routing protocols there. But I had to mess around with the administrative distance. But anyway, so that's your configuration for OSPF Not bad at all. It's pretty simple. They actually made it better. We don't have to worry about networks. All we need to do is just do a little configuration, sometimes in global, and then just enable it on whichever interface we want to do the process in. All right, so I'll see you outside the lab.
All right, there you go. OSPF, IPv6, router, OSPF, process ID number. You got to give it a router ID. Then you go inside the interface, IPv6, OSPF, process ID number, area. That's where you put it, area. And then I put area 0 because that is your backbone area. In real world, that's the first area you're going to create. All right. In a lab environment, you can do whatever. But in real world scenario, no, you have to do area 0. But that's it. Oh, and we did change the distance inside there to 80. And when we looked at the routing table, you saw that whatever you got from OSPF, whatever you learned from OSPF, when you looked at the brackets, you saw that that first number, which is your administrative distance, was 80. So now it's cool because when we looked at the interfaces, we saw a show start, you see RIP, EIGRP, and OSPF under there, where normally if you use only the defaults, EIGRP would be the only one in there, unless you have static routes, right? But if you change, that's what I'm saying, with all these routing protocols, whether it be IP version 4, IP version 6, you can tweak them, the distance and all that, and they can all coexist in there, but always the one with the lowest administrative distance is going to be in the routing tables. You saw all three of them were there, but only OSPF at the end made it to the routing table because he had the lowest AD and it was 80. There you go, OSPF for version 3. See you in the next. All right, one of the transition mechanisms, which is dual stack. Now, we're kind of doing it backwards because we're not transitioning to IPv4 because this is already an IPv6. This is our same lab that we did IPv6. I just added IPv4 networks. All right, so we're going to configure, we're going to put in IP addresses for IPv4 and then just do RIP for IPv4. And we'll see how they both can coexist together. You can ping 192.168.2.1 and you can ping an IPv6. They're both separate because they keep separate routing tables. All right, so they both can coexist. And that's the whole point, for you to have an IP version 4 network, obviously, first, and then slowly but surely, by sections, you can go ahead and start transitioning over to IPv6. And when you see that everything is working with IPv6, that you have connectivity and your applications and your hardware and all that supports it, then you can start taking out the IPv4 stuff. Okay, let's go inside the lab and get it done.
All right, so here we are inside the lab, the dual stack lab. Now, we're using the IPv6 routing lab for this. It's usually done backwards because you're transitioning, because this dual stack is one of the transition methods for IPv6. But just to show you that that it works, you can be running IP version 4 and IP version 6 routing protocols and IP addresses on the same interfaces and what have you, and it's just fine. That's the reason that they're called transition, so you can go from IPv4 to IPv6. In this case, we're doing it backwards. We're going from IPv6 to IPv4, but that's okay, as long as you know that it works. So first of all, let's go ahead and put the IP addresses on the computer. So let's go ahead and put 192.168. Okay, I fat finger the keyboard. 192.168.1.1. All right, tab 192.168.1.254. All right, we know this. This is what that LAS always uses. All right, let's go in here. This is the 192.168.2.1 and 192.168.2.254. Again, not making it complicated, just easy, just so you can understand the concept of what dual stack is. Okay. And then we go here, 192.168.3.1, tab, 192.168, .3.254. Okay, awesome. So we got the IP addresses on the PCs. Now, I mean, this should be easy for you to do, but now we need to, and we have the 10.114 and 10.118. So let's do these routers first. And as we're dealing with IPv4, it should be fairly simple. We don't have to go in the interfaces because we do everything from global configuration, right? Then we just do RIP, config T, router RIP, version 2, network 192.168.1.0, net 10.000, and then no auto summary, right? Don't forget that. UWR. Let's go over here. The middle router. It's attached to the 4, the 8, and the 2. So it's attached to 3 networks. Let's just maximize that CLI right there. So we got enable, config T, router RIP, version 2, network 10.000. Okay, and then network 192.168.2.0. No auto summary. UWR. That's pretty quick and easy. But you got to admit, the IPv6 version was pretty simple too. Okay, so we go enable, config T, conf T, and then router RIP, version 2, network 10.000, and then network 192.168.3.0. No auto summary. So now we can, let's do a show IP route. Now this is a version 4, and we're not getting anything. And that is not good. Why is that? Because we have no IP version 4 addresses on our interfaces. That's why. All right, so interface F0/0, IP address 192.168.1.254, 255.255.255.0, no shut. Interface interface S0/0/0, IP address 10.1.1.5, 255.255.255.252, and I have the clock rate already on there, so we don't have to worry about that. Okay, let's come here. Let's maximize it. Let's exit. Interface S0/0/1, IP address 10.1.1.6, 255.255.255.252, and then we go all zeros. IP address is 489. This is 9. Has the clock rate and everything ready. Then you can do a shot. It's all good to go right there. UWR. Oh, and the fast Ethernet interface F0/0, IP address 192.168.2.254, 255.255.255.252. No shut. UWR. Those are our 3 interfaces that we're connected to. Okay. And now we go to the last router. All right. So we go config T, interface S0/0/1, IP address 10.1.1.10, 255.255.255.252, and then interface F0/0, IP address 192.168.3.254. Oops, forgot the summary mask. 255.255.255.0. And then no shuts. And now, show IP route. Hey, there we go. Now we can actually ping 10.1.1.5. Awesome. And we're getting back from there. And then we have 192.168.1.254. So we have connectivity. You have 2 also there. So let's just put 2 just to check, because we have to check everything to make sure that we're good. All right, we're good. We can get wherever we need to go. But the cool thing about that is that you're running show. Let's do a show start. You're actually running both all right? You have an IP version, and what was this? I didn't have an IP version 4 address on this fastly10.0.0. Hold on. Oh, okay. I didn't copy it. All right, there's an IP version 4 address, an IP version 6 address. There's the IPv6 routing protocols. We never took them out. Okay, they're there, but we're also running, okay, version 2. So we're running both version 4 and version 6. Obviously, it would be the other way around. That's why we transitioned from version 4 to version 6. And this is the easiest way of doing it because it's simply just like that. You're running both protocols at the same time, and then you do it, segment by segment, portion by portion, like a pie, take a piece of it, and you make sure that everything is working as you go along. Once you see everything is working, IPv6, right, and is sending everything across, then you can slowly take out version 4, right? We just did it a little backwards, but you can see it's the same concept. Just running both IPv4 and IPv6 together on top of each other to go ahead and and run both protocols until we're ready to just use one. In this case, we really just want to use IPv6, not just IPv4. But both can run together without a problem. I'll see you outside the lab.
Tell you what, it's easier typing those IP4 addresses than it is IPv6, isn't it? That's why we can go so fast. But the good thing is, you saw when we did the routing protocol, which was the first thing we did instead of putting the IP addresses, but that's okay. So when we did the routing protocol, that was simple. It was RIP. RIP, router RIP, version 2, network, classful boundary for the 10 network, and then network 192.168.1.0, no auto summary. Boom. Next, 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 next. It was quick. It was easy. No problem. But obviously, we had to go back and put the IP addresses because we got so happy and full of joy to do the routing protocol that we just said, hey, the heck with the IPs. And that's why when we did show IP route, we saw nothing. And we're like, oh, okay, we forgot to put the IP addresses. But once we did that, you saw when you did show IP route, there was a routing table with RIP. All right, so that is a dual stack, one of the transmission mechanisms that IPv6 uses. See you in the next. Subnetting, the horror. We had issues with IPv4. We got it done. We're the masters of IPv4 subnetting. Now we will become the masters of IPv6 subnetting. All right, no big deal. We're going to take an address with a given prefix length or starting point, and we'll have to subnet it into 10 subnets. Once we get inside the lab, I'll explain all this stuff here. You see all these lines and all that, all these numbers. All right, so you'll understand how to subnet. Always turning everything into binary. And remember, these are hexadecimal numbers. Hexadecimal numbers. And remember, I use what? Positions, as I said earlier. All right, I'll see you inside.
All right, welcome everyone to the IPv6 subnetting breakdown. Okay, so now I doubt it if they're going to make you do some very complicated subnetting, if at all, in IPv6. But just in case they do, here we go. All right, we all understand that it's IPv6 is a 128-bit address. Each section or field, whatever you want to call it, is 16 bits long, which this portion of it right here gives us the network prefix of 64 bits. And this portion right here gives us a prefix of 64 bits. And obviously, this is considered your prefix length. Your prefix length. How many bits are on? All right. So if you're subnetting, the only one we're dealing with is in this particular section right here, the fourth section. Okay. So we take that forward. We have 1,000. We turn that into binary. Now, each one of these hexadecimal numbers, I call it a position. So the first position, second, third, and fourth. And we turn them into its binary format. And you can see here, all 3 zeros and a 1, all zeros, all zeros, all zeros. Now we have a starting point of 52. They've given us, this is the address they gave us, and they asked us to subnet. Okay, so what's the need? How many subnets do we need? Well, you need 10 subnets. Okay, so my starting point of each one is 16, 16, 32, 48. Then we got 49, 50, 51, 52, and the blue line says, hey, this is slash, or not slash, but prefix length 52, our starting point. We're counting from left to right. Okay, this is IPv6. I know it's different, but this is the only subnetting you do is with the network prefix. So we need 10 subnets. So 2, 4, 8, not enough. 16, plenty. We draw our new line. Our new prefix would be 56. And we increment by this particular value right here, 1, because those are the hex values, 1, 2, 4, 8. So since our line there, the bit value to the left, is our increment as usual. Okay? All right, so we're incrementing by 1 in what position? The second position, meaning this right here. This is the second position, the second 0. We're incrementing by 1. So how does that going to look? Well, if you look here, we always use the original number that was given to us. That's our starting point with the new prefix length. We'll always start by that. But now in the second position is where we're incrementing. And you can see right here by 1. So 1,000, and then you got 1 in the second position is 11, 12, 13, 14, 15, 16, 17, 18. And that's it for those subnets that we require. Those are the 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. So that's all there's to that. All right. Just to break it down a little bit more. All right. Or to give you a little bit more of an explanation. To drill it into your head, remember, it's the fourth section in the network prefix that you actually do your subnetting in. You see what your starting point is at, and you draw that line. Well, you break this into binary, obviously, and then you put where your line is supposed to be. In this case, this is 52, so we counted 49, 50, 51, 52. Boom, that's your starting point. And then you start counting from that on to from left to right, counting for however many subnets you require. And then wherever you stop and you draw your new line, whatever number or wherever you draw your line, the bit value to the left, that's your increment. As in this case, 1 was our increment. Okay? And you will always start with what you were given, and then you assign the new prefix to it, and then you start incrementing in the correct position. In this case being position 2. That's all there's to it. Now you have access to this particular handout anyway, so you'll have it, or you can always get the book. The only IP book you'll ever need is on Amazon. It shows you IPv4 and IPv6. That will help you out. That diagram is in there. Okay, that diagram is in there to show you exactly how to subnet. All right, both at IPv4 and IPv6 plus other things. All right, but that's it. That's all there's to it to subnetting in IPv6. I'll see you outside the lab.
All right. Subnet IPv6. What do you need to remember? The fourth section or field is what we use to subnet. You're giving a starting point, which was 52, prefix length. You turn that fourth section into binary. You put its binary, you put all, the 4, 0, 0, 0, 0, whatever, the 4 bits, right? And you count because the first 3 sections were 16, 32, 48, 49, 50, 51, 52. That's where you start. That's your starting point. You needed 10 subnets. You count 2, 4, 8, 16. I know it's weird, okay, but we still do the same. All right, 2, 4, 8, 16. You draw your line. That's your new prefix length. What's the bit value to the left? 1. So you increment 1 on position 2. That's where the positions come in, right? And then you say, okay, well, I start with the original number they gave me, which was 1,000, with a new prefix length, and then I'll increment by 1 on the second number, on the second bit value, right? So it's 1,000, 1,100, 1,200, 13, 14, 15, 16, 17, 18, and 19. And that's it, you're done. It's that simple. It could get complex. They may want other levels of subnetting. Doubtful for CCNA, you're going to have to do that. All right. Doubtful for any other test that you have to do subnetting in IPv6. All right. But if they do throw this basic subnetting in there, that's what it is. That's all it is. Okay. So you'll have access to this. If not, I mentioned it inside the lab. You can always get the book. It's in Amazon. The only IP book you'll ever need. All right. And that will explain. The diagram will be there. The explanations will be there. So you can have it. But I'm going to go ahead and see if I can upload it. Hopefully the e-learning site will accept an Excel spreadsheet. If not, I'll take a picture of it. I'll put up a JPEG. All right. Well, that's that. That's subnetting and IPv6. See you in the next. We made it through IPv6. Not bad. Not bad. Okay. Let's see what we went over. We went over all the pretty much the basics and things that IPv6 helps us with. The new stuff, the new features, why you want to go to it, right? IPv6 is more streamlined than IPv4, and the new addresses, all these different things, right? It's more addresses, not only new, but more. All right, so we're not going to have issues later on. There's issues now, obviously, security. I explained with the ICMP, the router solicitation, router acknowledgement, neighbor solicitation, neighbor acknowledgement, all that. So you got to be very careful with the ICMP version 6. Don't block it. Don't block it. All right, and then we went to assigning an IPv6 address. That wasn't so bad. We did the static routing. It's pretty much the same thing, except we do IPv6 route, and we put the network prefix with the prefix length as one, and then we put the exit interface. That's it. Easy peasy. Then dynamic routing, we did all three routing protocols. We did RIPng. That was not bad at all. EIGRP, we just got to remember to turn it on and give it a router ID. And with OSPF, we got to give it a router ID. Because if you put the process ID number, you're going to get that little warning sign, hello, can't start the process until you give me a router ID. And then, okay. All right, so you go ahead and do it. And then you enable it. All the routing protocols for IPv6, you got to put them inside the interface. You got to put them inside the interface. And with OSPF, the area, you do it in there. IPv6, router, OSPF1, area, and whatever area that particular area you're in, 0, whatever it is. All right, so that's it. Oh, and then we did the dual stack, kind of backwards, because it was already in IPv6. I just wanted to put in the IPv4 in there. And you saw how both created two routing tables because they're separate to each other. They both can run on top of each other. And then we learned a very basic subnetting of IPv6 by using my method, which is using the positions, putting everything in binary, finding the same things we do for IPv4. Draw your line, find the bit value to the left, where do you increment? Start with the number that they gave you with the new prefix, and then increment by whatever position that bit value is in. And you'll be good to go. All right, but that's it. That's all there is to this section on IPv6. See you in the next.